Now we come to what they call rules of derivative. Rules of derivative, it's exactly the same thing as this. This is a longer way of doing derivative. So you're going to what we call, I can say it's shortcut. Now first I want to tell you that when we say m, which is gradient, another way to write it, we can write f prime x. Another symbol of writing that is to write y dash. Another way is to write dy all over dx. It's still the same thing. Another way to write this, you can say d, because y is the same as f of x, is d f of x, and then over dx. Sometimes they can write a big D, meaning derive with respect to x, and they put square brackets. Now they put an equation inside there. All those things means exactly the same thing. Okay? Okay, it's just symbols. There's still other ones, but this one I think we're okay with this one. Now, I'm giving a rule, a shortcut. So if I'm given, let's say f of x equals to, I'm going to write k is the coefficient of x to the power of n. So always you make sure the x, it's at the top, it's numerator. It cannot be at the bottom. It has to be at the top. It can be at the bottom, but you can bring it to the top. It can be at the bottom and you can cancel it and make it disappear. For your case, it must be at the top, that x and the power. We good, ne? So, when you derive f prime, doing exactly what we've been doing with first principle, but the shorter way of doing it, the number there at the top, there, that n, it must come and multiply the coefficient. So it becomes n times the k. If there were numbers, you'll know how much you're going to get. And then times the x. There, that exponent, you reduce it by 1. You make it less by 1. You minus 1 from it. Then it's n minus 1. Case closed. You are finished. Once you understand this, we are already done. Okay? Let me give you a quick example. Remember, it's the same thing. If we call it y, I could have used y, dy over dx, or y prime. Any symbol that I want. Say, for example, I've got y equals to 3 x to the power of 4. All right. So when I do y dash, okay, the x is already numerator. So the 4 must come and multiply the 3. If I write it step by step for now, it's 4 times 3. We good, ne? Times the x. That 4, I must minus 1 from it. This is step by step, right? You don't have to. But now you know better now. The 4 must times the 3. 4 times 3 is 12, correct? And then the x, I subtract 1 from it. It becomes 3. You are done. All right. Now let's give another example. What if I'm given y equals to 5 x to the power of, let's say, of 4 minus 3 x squared plus 7x and then plus the 10. You good, ne? Now, every number here, it has the x with the power. This one has x with the power of what? 4. This one has x with the power of what? 2. This one has x with the power of what? 1. This one also, though you don't see the x is there with the power of 1. Because 10 is the same as 10 times 1. Isn't it right? But what is 1? 1 is the same as x to the 0. You see, a number without the x, it is the number with x to the 0. You good, ne? You're going to need this. All right, that's why when we do this one, we say the answer is 0. You're like, where did it come from? The power is there, okay? All right, so I'm writing it without, but you need to know it's there, okay? Okay, anyway, let's just keep it there for now, because you'll get it without, ne? With you can put a pencil or memorize. When the x is not there, that thing becomes 0. You're going to see it now. All right. So now here we go. We're now saying, 5 times the 4. dy over dx equals to 5 times 4, it's 20. Am I right? X to the power of 3. Then 2 times minus 3. It's negative 6. And then 2 minus 1 is just 1. No need to put it there. And then plus. This one, there's a 1. Remember? All right. Let's just put that one because usually it's these two. This one and the one. They're the one that makes people to do mistakes. So it will be 1 times 7, which is 7, isn't it? Okay? Come on. 1 times 7 is 7. Okay? And then x. 1 minus 1. It's 0, ne? We got any number to the 0? It's 1. So this is the same as 7 times 1. So which remain? 7. So whenever it's just the x, when you derive, you only keep the number. But we're still using the rule. You good? I did take the 1, bring it in front, and subtract 1 from it. I did. All right. Then plus 0 times 10. What you got? It's 0, ne? Times x. You got 0 minus 1, which is minus 1. X to the minus 1. Can you see? What is 0 times anything? Yeah, so this part becomes 0 regardless. So that's why it will be just 0. Or sometimes we don't even show it. Are we happy now? All right. Let me focus on this one and that one just to drill it home. So if you give me y equals to 6x. So when I do y dash, I know the answer is just the 6. We good, ne? So if you give me y equals to 20, because it's without the x, when I do the y dash, I know it's 0. I'm still applying the rule. Case closed. You got it, ne? This is example 1. I'm going to go to examples number 2.